We will hear from Mr. Jung-ung, manager at the Korea Electronics Association. He will present on the topic, current status and challenges of circularity assessment system for EEE in Korea. Please welcome him.
Is Daniel and I am from the Korea Electronics Association. I am delighted to have this opportunity to share information about Korea's program at the Korea EU Ecodesign Forum. I would also like to thank KITECH for the invitation. I would like to discuss the current status of the Material and Structural Assessment Scheme, which was created to encourage eco-design and improve the recyclability of electrical and electronic products. I would also like to address the challenges facing the industry. I would like to cover three main points: an overview of the Material and Structural Assessment Scheme, operating results for 2024, and challenges and implications for the electronics industry. The appendix contains slides detailing the legal framework of MSAS, the 49 product categories, and the evaluation criteria. Due to time constraints, I will omit my explanation of the appendix. Thank you for your understanding. The MSAS is a self-assessment program implemented since 2008 to improve the recyclability of electrical and electronic products. From now on, I will refer to it as EEEs. Every year, domestic manufacturers and importers select representative models for each product group, evaluate improvements in materials and structure, and submit reports to the government. The purpose of this program is to improve the recyclability of EEEs, reduce hazardous substances, raise companies' awareness of eco-design, and promote recycling activities. This program applies to manufacturers and importers of 49 types of EEEs. The products covered are those designed for use with direct current of 1,500 volts or less, or alternating current of 1,000 volts or less. There is no distinction between household and commercial use. A representative model is a model that a company used to conduct assessments. One model must be selected and evaluated for each product group once a year. Selection criteria are based on production or import volume. The Ministry of Trade, Industry and Energy and the Ministry of Environment jointly implement this program, and the KEA is responsible for receiving and verifying assessment reports. Companies are required to prepare and submit material and structure assessment reports, as well as retain records of evaluation activities. Those that fail to submit these reports will be subjected to fines. Additionally, manufacturers must incorporate material and structural improvements into the design stage, and importers must confirm that suppliers have implemented these improvements during the import process. As the law states that make efforts, this is not a mandatory requirement. However, it is an important factor in evaluating material and structural improvement. The MSAS assessment criteria consists of three aspects: material, structure, and management system. The directive also defines evaluation criteria for material and structural improvements, but they are more like a framework. KEA determines more detailed assessment criteria based on its own standard CE 3300. In terms of material improvements, a company evaluates simplification of plastic material types, expansion of recyclable plastic use, whether material symbols are marked for plastic parts, and degree of increase in the use of recycled materials. In terms of structural improvement, a company evaluates ease of separation, ease of disassembly, improvement in single material structure, degree of reduction in raw materials, degree of product volume reduction, and packaging material weight ratio and reduction degree. With regard to management systems, a company evaluates whether pre-assessment registers are kept, whether recycled information is provided to interested parties, whether recommendations are implemented, whether R&D is conducted, and whether the products are manufactured considering the environmental impact. This scheme's operational process can be divided into two main stages. The first stage is pre-assessment. Manufacturers conduct assessments to reflect the material and structural improvements in the design process, and importers conduct assessments to confirm the material and structural improvement efforts of overseas suppliers when importing products. The next step is the submission of the assessment report. Companies must submit their assessment reports to KEA by July of the following year after manufacturing or importing occurs. KEA verifies and reviews the appropriateness of the assessment reports and submits the results to the government. As the submission of assessment reports is still ongoing this year, I would like to describe the results for 2024. A total of 513 companies submitted 1,128 assessment reports in 2024. As the table below shows, manufacturers account for 26% of the domestic appliance market, importers account for 56%, and companies that both manufacture and import account for 18%. The fact that pure manufacturers account for only 26% indicates that importers have a very large share of the domestic appliance market. The chart on the right shows the number of assessment reports, or the number of models for which assessment reports were submitted. Computer product groups account for the largest share because they include various peripheral devices such as monitors, electronic whiteboards, keyboards, and mice. Small appliances are generally imported products, and the number of assessment reports submitted for these products is also high. Now, I'd like to discuss the results of each question. First are the questions regarding material improvement. In terms of the number of plastic material types, there are products with only one type. Most products have 2 to 5 types, while products with 6 or more types account for over 20%. In the case of labels and stickers, almost all products use removable labels or engraved markings. In the case of plastic material labeling, 32% of products still do not comply with ISO standards. This shows that although unimaterialization is an important factor in expanding plastic recycling, it is a very challenging task for companies. And the larger the product, the more types of materials tend to be used. In addition, overseas original design manufacturer, ODM suppliers, and even further, their component suppliers often label plastic materials in ways that do not comply with ISO standards or do not label them at all. Therefore, raising awareness of material labeling among overseas suppliers is also an important task. In terms of recycled plastic use, 73% of products do not use any recycled plastic. This shows that using recycled plastic is a very challenging task for companies. It is positive that nearly 90% of products have eliminated PVC. In the case of synthetic resin packaging materials, 26% of products do not use them at all, and 34% of products use less than 5%, indicating steady progress in replacing synthetic resins with paper. The following questions are related to structural improvements. First, in terms of ease of separation, nearly 90% of products are considering ease of separation during design progress, and 96% of products can be separated using already standard tools. In terms of the number of joint types, more than half of the products can be disassembled with only one or two tools. However, some products have a large number of joint types and need improvements to simplify the fastening method. The following questions are related to the management system and are categorized by manufacturer and importer. In the management system section, we examine one, R&D efforts to promote recycling, two, eco-design processes, three, considerations of environmental impacts, four, record management by provision of recycling information to stakeholders, and six, whether product improvement were made in response to stakeholder requests. Many responses to question 6 were no, because even companies that have never received requests from stakeholders answered no. In the case of manufacturers, more than half have management systems in place for R&D, eco-design processes, or providing recycling information. However, many companies still lack these systems. The following are the responses from importers. Although some are specialized in appliances, many are trading companies and distributors. Importers face many difficulties when introducing eco-design systems because they lack R&D personnel and departments. Nevertheless, it was found that over 20% of companies have set up systems for collecting and recycling products, as well as for providing recycling information to stakeholders. Based on the assessment results, we have identified 3 challenges and implications that the domestic electronics industry is facing. The first is data collection and verification. The domestic home appliance industry has a higher proportion of importers, and with global supply chains diversifying to China, Japan, Vietnam, and the EU, cooperation with these chains is necessary to collect and verify material and structural data. ODM importers lack R&D personnel, and they have to rely on ODM suppliers for material and structural assessments. They also lack the ability to verify the accuracy of the information provided by suppliers. Regarding the content of recycled materials, many overseas product or component suppliers either do not provide analysis data, respond with simple email replies or official documents, or even refuse to respond at all. Tools need to be developed to improve overseas companies' awareness of and accessibility to Korean programs such as global websites, promotional materials, guides, and tools. Data verification should be approached from the perspective of limited assurance rather than reasonable assurance, as the former is more realistic. The second are technical and market barriers. Product groups that have been on the market for a long time have limited potential for improvement. There is also a tendency for the number of plastic materials and joint types to increase with the size of EEs. Small appliances, even when designed for easier disassembly and separation, face the limitation of producing only a small amount of recoverable raw materials. There is a significant variation in product size and shape within the same product group, making it difficult to impose uniform material structure requirements. There is a trade-off between market consumption trends and material and structure. For example, the trend toward larger TVs improves functionality but makes it difficult to reduce weight or increase recycled content. A shortage of recycled plastic supply is a major challenge for the domestic appliance industry in increasing recycled material content. Material and structural benchmarks and best practices need to be developed by analyzing various types of physical models. And reasonable assessment criteria for material and structural improvements need to be developed based on market trends and product analysis. The third is accelerating the eco-design capabilities of SMEs. The expansion of the Korean Extended Producer Responsibility Program to cover all products, the Promotion Act for the Transition to a Circular Economy Society, the EU ESPR, and the Ecodesign are among the environmental changes, both domestic and international, that require more products to meet stricter requirements. Developing an eco-design process and conducting R&D on material and structural improvement remain significant challenges for small and medium-sized enterprises, particularly importers, due to limited capital and human resources. It is anticipated that more new companies and products will be subject to the material and structural assessment scheme in the future. However, regulatory measures alone have limitations in achieving qualitative improvements in industrial circularity. We need to support the establishment of an eco-design management system, provide guidance on preparing material and structural assessment reports, promote outstanding companies and products, and support the development of unimaterials. Developing and disseminating a differentiated eco-design management system model for manufacturers and importers is necessary to raise awareness that eco-design is not exclusive to manufacturers. Today, I focused on the current status and implications of the Material and Structural Improvement Assessment Scheme, but I believe that this case can also provide valuable insights for the EU ESPR and eco-design policies. Therefore, I hope that circular economy and eco-design policies will be successfully established in South Korea, the EU, and other countries. This concludes my presentation. Thank you.
네, 엄정훈 과장님 발표
Thank you very much, Mr. Basically, he gave a presentation about MSAS, Material and Structure Assessment Scheme of Korea. Data gathering and verification and the lack of supply of recyclable plastic and SMEs' difficulties and need for support. So he gave details about these topics. Nevertheless, this scheme is not mandatory scheme, so it has limitations because it's based on voluntary basis. So it's very hard for home appliance companies to actively participate in this system. With this system alone, do we think we can sufficiently respond to the EU ESPR, which is a very strong regulation? In the panel discussion later, in order to respond to the EU ESPR, how we need to improve our domestic schemes and systems. If you give us more supplementary explanation, it will be great.